the world who are joining us for this event. So again, extra special welcome. My name is Professor Paul Traherne, and it's my privilege to introduce the winner of the Widdowson Award, Professor Anne Prentice. I should say that we were briefly colleagues in the Dun in the early to mid 1980s, albeit in different groups. Before introducing her, I would like to say a few words about the award itself. Several years ago, the trustees of the Nutrition Society, and I was a trustee at the time, agreed to establish a series of senior awards reflecting the highest levels of achievement in nutrition research. It was decided that there should be 3 awards and that they would represent the key areas of nutritional science, and that they should each be named after a distinguished figure within that area and of someone who had also made a substantial contribution to the Nutrition Society itself. One award is for contributions to whole body metabolism and animal nutrition, and this is named after Sir Kenneth Blackster, the former director of the Rowett Research Institute in Aberdeen. Sir Kenneth was president of the Nutrition Society in the mid-1970s. The first Blackster Award was presented in 2018 to Professor Keith Frayne from Oxford. The second award is for contributions to molecular and cellular nutrition, and this is named after Sir Frederick Gowland Hopkins, Order of Merit, who won the Nobel Prize in 1929 for the discovery of vitamins. Sir Frederick played a major role in the founding of the Nutrition Society at the beginning of the 1940s, and the first Gowland Hopkins Award was presented last year. The third award is for contributions to public health nutrition, and it's named after Dr. Elsie Widdowson, FRS Companion of Honor. She was president of the Nutrition Society between 1977 and 1980. She had a highly distinguished career in nutrition, making multiple contributions to the subject, but she's perhaps best remembered for the indispensable composition of foods, the first edition of which appeared in 1940, which she wrote with her close collaborator, Professor R.A. McCants. In 2015, the 7th edition of McCants and Widdowson was published. It's therefore highly appropriate that the Public Health Nutrition Award should be named in her honor. It's also particularly appropriate that the first winner of the Widdowson Award should be herself not only a distinguished scientist, but someone who was director of the MRC unit named after Dr. Widdowson, the Elsie Widdowson Laboratory in Cambridge. Professor Prentice's first degree was in chemistry at Oxford, and this was followed by a master's at Surrey and a PhD in Cambridge. She joined the then MRC Nutrition Unit in 1978 to work with the director, Professor Roger Whitehead, and his team, which was based in the Gambia with complementary studies in Cambridge. Her work in the Gambia focused on pregnancy and lactation in mothers on marginal diets. Since returning from the Gambia in 1983, she's been based in MRC units in Cambridge, though continuing to undertake research in the Gambia. Her work for the past 40 or so years has centered on life course nutritional requirements for population health, with an emphasis on calcium, vitamin D, and bone health, areas in which she has long been recognized as a major international leader. Apart from her direct research work, she served on a number of national and international nutrition committees, including as chair of the Scientific Advisory Committee on Nutrition here in the UK from 2010 until this year. She's also received a number of honours and awards, and I would highlight just 2 of them. Election as a Fellow of the Academy of Medical Sciences in 2012, and the award of an OBE in 2006. Anne is currently Honorary Professor of Global Health and Nutrition, Global Nutrition and Health at the University of Cambridge, and leads the MRC Nutrition and Bone Health Group, which is based both in Cambridge and the Gambia. I think it's fair to say that it would be difficult to think of a more appropriate winner of the inaugural Widdowson Award. So I'm delighted to welcome Anne and to ask her to give her lecture, which is entitled Hard Facts and Misfits, Essential Ingredients of Public Health Nutrition. Anne, please.
Thank you very much indeed, Paul, for your extremely generous words there. And I must say, I feel extremely honoured to have been selected by the Nutrition Society for this prestigious award. I'd like to thank the Society, the members of the panel who selected me, of course, and my nominators. There are 5 people out there who are probably watching at the moment, and I'd like to thank them very much for putting me forward for this award. It's made particularly special for me, as Paul was alluding to, because of the close connections that I felt with Elsie Widdowson throughout my career. Somebody I long admired from the very first go, but of course we had more close connections in latter years, and especially when she graced my laboratory with her name shortly before she died. I named this talk Hard Facts and Misfits, Essential Ingredients of the Research that goes into public health nutrition, in order to think really very hard about what it was that has really solidified for me the way in which my research career has developed. And I want to mention some of the most amazing people that I've had the opportunity not only to work with, but to be inspired and indeed to be mentored by. And that's Elsie Widdowson herself, Roger Whitehead, who you've just heard about, the director of the Dun Nutrition Unit and my boss for 20 years. The late Chris Bates, world expert on vitamins, needs no introduction to most of the Nutrition Society. Tim Cole, my guru on all things logical and mathematical and biostatistics. And John Pettifor in South Africa, pediatric endocrinologist and an expert in vitamin D and bone health. And I think they probably have set the tone for me, certainly over the years, about the incredible importance, the essential importance of evidence to underpin public health nutrition, hard facts, objective measures, and so forth, rigorous studies. The misfits, and I called it the misfits because these are the data, the results that don't fit what you're expecting, and that is really, really hard. And Elsie Widdowson was the person who said to me once, you know, it's the results that don't fit that matter. They're the ones you really should be investigating. They're the exciting ones. To look at underpinning mechanisms, attention to detail, of course, extremely important, and the importance of interpreting messages for public health. And I'm struggling very slightly because of my PowerPoint, but I've now got it back on the screen. I hope everybody else can see it. I'm not going to go through my biography because you've just heard about it from Paul, but to think about the hard facts and misfits, I just wanted to point out that actually my training has not been in nutrition. It's been in the evidence-based empirical sciences of chemistry, medical physics, and then in my PhD when I undertook studies trying to develop biomarkers for cancer research. So all of those things really have fed into my career as we have gone forward. I joined Roger Whitehead's team, as you heard, back in the late 1970s, and I joined the team in the Gambia. And at that time, the big puzzle for Roger and many other people who were interested in global public health nutrition was in why children from poor resource communities grew so badly in the first few months of life and in early years, the growth faltering. And it was the consensus at the time that this was very much due to the poor nutrition of the mothers, which would result in the low birth weight of the baby, and because of their long breastfeeding periods, that they would be unable to produce breast milk of adequate intake or adequate volume and adequate quality. So at the time, there were proposals for a number of nutrition programs in different countries to feed the mother and thereby feed the child. And indeed, some mothers who had poor diets were advised not to breastfeed at all. But all of this was based on extremely limited evidence and often using inappropriate methods. And at the time, Roger Whitehead, as you heard, had set up the ability to undertake cross-cultural studies to compare and contrast mothers in Cambridge, obviously an affluent English city with good diets, largely good health and so on, relatively small families, but where breastfeeding itself was common, with Kenaba, the Gambia, a poor rural farming African village where the people had marginal diets, seasonal food shortages, agricultural period of hard labour in the fields, and high prevalence of infections. And the ladies there would breastfeed for at least 2 years as a universal. And so it was our job as the team to set up objective measures so that we could really look at pregnancy outcomes and lactational performance in order to provide the evidence for feed the mother, feed the child. And we got to know the local people, of course, and understood the way in which they breastfed and trying to preserve their culture and so on in trying to do these measurements, while we introduced methods from Cambridge that were being developed by our colleagues back home. For example, the deuterium oxide dose to the mother method of measuring the breast milk intake of babies in a very objective, non-intrusive way. My job was to set up a laboratory so that I could validate measures for looking at breast milk quality and undertaking the composition of local foods. And that I did, and we used to have samples that were sent out from Cambridge for me to measure while I was in the Gambia. And to cut a very long story short, the results of those studies were that we showed that although their diets were very poor, the women in the Gambia had reasonable breast milk volumes. They were certainly able to produce intakes for their babies anywhere as near as good as in Western countries, and of reasonable breast milk quality. That was not true for women who really were very undernourished, but by and large they had good lactational performance. The team undertook a number of trials using maternal dietary supplementation in order to see if this would improve the lactational performance of the mothers by giving a protein energy rich biscuit and a tea drink that contain micronutrients. And the long and the short of it is that those studies, those trials, showed no significant effect on breast milk intake and relatively little effect on breast milk quality, with the exception of the water-soluble vitamins. The pregnancy supplementation did have an effect on the growth of the baby. The low birth weight prevalence was decreased and perinatal mortality was reduced. But this was only in the hungry season when really food restriction was at its greatest. So it was not year round. What happened as well was that the mothers gained weight, which of course was probably to her advantage, but it also decreased the prevalence of energy sparing. And so it was altering the adaptive processes for this mother, which in its own right may well not have been to her advantage. And similarly, the lactation supplement had the same effects in many ways. It increased the weight of the mother, but it helped the mother to produce breast milk without needing such high prolactin concentrations. And that in itself will have reduced the period of amenorrhea for that mother, and had it gone on longer, might well have decreased birth spacing, which again may not have been to her advantage. Now, all of the work I've just described was the work of a large team of people, and as I said, my particular role in that was measuring breast milk quality. And one of the misfits of those studies was the recognition that the breast milk calcium content of the mothers in the Gambia was some 25% lower than that I was measuring in mothers from Cambridge. I also showed that breast milk calcium concentration, it does go down through lactation. Everybody finds that in their studies, but it tracks individually within the individual. And there appears to be no relationship either with the volume of milk that the mother is producing. And so, of course, that implies that those infants in the Gambia were in fact receiving 25% less calcium than their breastfed peers in Cambridge. I'm sure I don't need to tell this audience that, of course, we need calcium, the other bone-forming minerals, and vitamin D for good bone health, for the growth of the baby in the womb and breast milk calcium, and other aspects of health of the mother, to grow the skeleton for the child and to avoid stunting and rickets, and for bone health throughout life, and again to avoid fractures and osteoporosis in older life. Well, back in the 70s, early 80s, we set about considering the importance of raising the calcium intake for these people in the Gambia, given that even from the word go, from infancy, calcium intakes were extremely low. We undertook a series of analyses of Gambian foods and showed that the calcium intakes would be extremely low in this non-dairying population from infancy right through to old age, much less than were currently being recommended internationally. And so there were, of course, possible benefits for these people for increasing their calcium intake. But one of the puzzles, even at that stage, one of the misfits was that hip fractures in older age and osteoporosis appeared to be uncommon, which again was going counter to current perceptions in the West. And it was at about that time that Dr. Elsie Widdowson was awarded the Rank Prize Prize in Nutrition. And with that prize, she endowed a fellowship with Roger Whitehead at the Dunn Nutrition Unit, who was placed to work with me on calcium requirements in the Gambia. And that was the start really of, well, 30 years worth of work within the Nutrition and Bone Health Group, which we started to form at the time. And those of you who've been to some of my talks before will know that during that time I've worked throughout in the UK and the Gambia, and in a number of other African countries, in Bangladesh and in China, comparing and contrasting populations with a high and a low calcium intake or high and low vitamin D status, and of course different ethnicities, in order to provide the evidence about whether having a higher calcium intake or a better vitamin D status would be good for those populations. My medical physics background meant that I could introduce, as soon as they were available, scanning modalities that would enable us to look at the bone mineral content of the skeleton in healthy people, in infants, in children, and in mothers as well. And when the very first single photon absorptiometers were licensed for use in that way, we were able to purchase one and introduce it into the Gambia. Since that time, I've been very fortunate to be able to upgrade the scanning facilities both in Cambridge and in the Gambia, and we now have PQCTs, that's peripheral quantitative computed tomography, for measuring the peripheral skeleton, and the modern IDEXs for whole body, spine and hip. The first studies that we undertook to try and answer the question, would an increase in calcium intake benefit people in the Gambia, were in lactation and in pregnancy. Pregnant and lactating mothers, we had worked out by then, consumed about 300 to 400 milligrams of calcium a day only, about 3 to 4 times less than were being currently recommended at the time. The lactation study was for 12 months after birth, giving calcium carbonate to these mothers, and we measured breast milk composition when we looked at the bone content and biochemistry and infant growth. A much larger trial, a pregnancy of 600 women, was powered so that we could also look at maternal health outcomes such as blood pressure. But again, we use calcium carbonate, bringing the intake of those mothers up to levels that were currently being recommended for pregnant women. And we did not get the results that we were expecting, some more misfits. We had expected the calcium concentration of the milk to increase for these mothers, but it didn't in either the lactation trial or the pregnancy trial, and the growth of the infant was not affected. We had good compliance amongst these women. The calcium supplement had no effect on their breast milk, or on the birth weight or length of the baby, or on the bone development of the baby or growth in infancy, nor on the mother's blood pressure. However, at that time, I was also undertaking studies of bone health in lactating mothers in Cambridge, and we were able to show, which was subsequently shown by many other research groups, that women who are breastfeeding have a physiological mobilization of bone mineral from the skeleton. And that occurs in the first few months of lactation and is reversed towards the end of breastfeeding when menses return, and then after the cessation of breastfeeding altogether. In Cambridge, where women in our studies had calcium intakes that were very similar to those recommended or indeed higher, we were unable to show any relationship to calcium intake at all for these mothers in terms of their bone mobilization. But as I said, they had a relatively high calcium intake, and so we looked at this in terms of our Gambian mothers. We anticipated that what we would see is that the mothers who in the Gambia who were on our placebo group would have an accentuated bone mobilization because of their very low calcium intake, and that this would be ameliorated by giving the extra calcium. But in fact, the reverse was true. And what we found was that women who had been supplemented in lactation, there was no difference in bone mobilization between those who'd received the calcium and those who hadn't. And those in the pregnancy trial, which I'm showing in the slide here, the women who had received the calcium supplement in pregnancy had greater bone mobilization and had lower bone mineral after 12 months of lactation, when of course they were in full lactation at that stage. So we followed these women up 5 years later when they were no longer pregnant or lactating, and they may have had another child or two in between, and we found that those supplement differences still remained. So the women who'd been in the placebo group, their skeletons behaved exactly as we had expected them to, with the recovery of bone mineral of the spine and the hip. But this had not happened in those who were in the calcium group. So of course there was a lot of heart searching for us over this. This is possibly a persistent deficit that had been caused by providing this extra calcium for the women. And so we have followed them up even further, and we've just finished the 20-year follow-up of nearly 400 women during midlife in order to see what has happened to their skeletons since that time. But very definitely an unexpected finding. Given it was unexpected, we felt that we should also follow up the offspring of these mothers to see if the calcium supplement had a benefit or otherwise for the children. We had not shown any difference during infancy, but we have followed these children for some time now. Every 2 years from 3 to 11 is what I'm showing on the slide. These are unpublished figures, but as you can see that we did find effects on the growth of the offspring of these mothers during their childhood. And curiously enough, sex specific. So we've shown faster growth in boys whose mothers were in the calcium group compared to the boys whose mothers were in the placebo group, and slower growth in the girls whose mothers were in the calcium group compared to those girls whose mothers were in the placebo group. And there were also sex-specific effects of the in utero exposure to calcium on blood pressure. Serendipitously, at the age of 7 years, these children also participated in a study where a blood sample was taken. And this gave us an opportunity to look at the growth factors in their blood. And we showed that girls had higher IGF-1 than boys at the age of 7, which perhaps was not a surprise. Girls enter puberty earlier than boys generally, or they have an earlier growth spurt. But we did show sex-specific effects in line with the results that I've just shown you in IGF-1, such that the boys whose mothers had been in the calcium group had greater IGF-1 in their blood than boys whose mothers had been in the placebo group, and the reverse was true for girls. So when these children became big enough for a useful DEXA and PQCT scan, so at the age of 8 to 12, we also measured their bone development and shown exactly the same thing, with boys whose mothers were in the calcium group having grown faster than the boys whose mothers were in the placebo group. But the reverse was true for the girls. And we're now following up these children into adolescence and out the other side. Why this has happened, we don't know, but the results had some real resonances for an earlier trial that we'd conducted some years ago in prepubertal children in the same area of the Gambia. This was an intervention of the children themselves who received calcium carbonate or a placebo for 12 months at a time when they were about to enter puberty. 90% of them were Tanner stage 1. And we found in that trial, we found the expected increase in bone mineral content with the increase in calcium that they had received, with a decrease in parathyroid hormone and bone turnover, again, as one would be expected from studies that have been carried out in the West. But we found no effect on growth during that time, on height or on the size of the skeleton. And therefore it was considered that the result was likely to be a remodeling transient. I haven't got time to go into the complexities of remodeling in the skeleton, but what that did imply was that we were expecting to see the increase disappear again when the children were no longer receiving the supplement. But actually 12 months later, again, another misfit, that is not what happened. And we showed that these children had greater bone mineral content after 12 months. The parathyroid hormone levels remained low or lower than they had been, suggesting that the calcium carbonate supplement had altered their adaptation to their low calcium intake, which again may not have been to their benefit. And so those children were followed regularly every 2 years to adulthood with bone scans and growth. And the results for that were really quite surprising for us, because we found, again, sex-specific effects on the growth to young adulthood, only in the boys. So the boys who had been in the calcium group, they entered their pubertal height spurt about 7.5 months earlier than the boys that were in the placebo group, and the peak height velocity followed at the same time as it would be expected relative to when they entered puberty. So in mid-adolescence, these children, these boys, were taller by about 2 centimeters than the boys in the placebo group. But they also came out of their pubertal spurt earlier as well, so that when they were young adults, they were actually shorter by about 3.5 centimeters. We were very fortunate to have been collaborating with Tim Cole and his sitar models to be able to show that granulation of pattern in the height for these children. We found a similar pattern for weight, for mid-upper arm circumference, and for the various variables of bone, although not all of them were significant by the time we got to adulthood. But as you can see from the graph there, we found no similar effects in the girls. And so that has posed a question that's still standing in a way, which is the question that is increasing the calcium intake for populations with a low calcium intake by Western standards invariably beneficial? Well, one area where we think it may well be, and that's in rickets. Nutritional rickets in many parts of Africa and Asia, the rickets patients do not appear to have frank vitamin D deficiency. There are places where that is exactly what's causing their rickets, D deficiency, but there are many patients, many areas where that is not the case. And that included the Gambia, in South Africa, and in other places, and our recent work in Bangladesh. These children have a vitamin D status that's well above the level that you would imagine meant that they have vitamin D deficiency. They also have raised parathyroid hormone and 125 dihydroxyvitamin D linked to a very low calcium intake, and also phosphate loss causing the rickets. Now, in this area of the Gambia, we undertook a survey of all the children living in the province of West Kiang in order to look at the prevalence of rickets-like deformities, rickets and rickets-like deformities in these children, and showed that actually there was a percentage there of around about 4%, and 8% of boys and 3% of girls. So again, a preponderance of boys being affected by this problem in the Gambia. One of the findings from our studies were that the rickets patients in the Gambia had persistently high levels of a phosphate regulating hormone known as FGF23, fibroblast growth factor 23, measured by the C-terminal assay. And this high levels of this hormone relate to kidney phosphate loss or the excretion of phosphate through the kidneys, and can lead to hyperphosphatemia when it's elevated. And John Pettifor and I put together a hypothesis where we linked the very low calcium intakes in the Gambia to raised parathyroid hormone, so forth, persistently raising FGF23, leading ultimately to phosphate loss and rickets. Now, that's turned out to be not as straightforward as we thought, and we think we found an interaction with iron deficiency there, which produces essentially inactive fragments of the C-terminal fragments of FGF23 in the blood of these children, and not necessarily the active hormone. And so, although our original hypothesis may be part of the story, we don't think it's now the whole story, and there appears to be a relationship between the low calcium intake and the metabolism of vitamin D, causing it to be broken down more rapidly. But that is work in progress. We don't know that is the case yet. We have recently published work from Bangladesh, where we have been looking at the same problem. This area of Bangladesh that we've been working in the Chittagong area, has really quite a marked epidemic of rickets, as you can see from some of these photographs. And these children all do have very low calcium intakes, as do their healthy children who are living alongside them. The children with rickets appear to have suppressed FGF23, so that's quite the reverse to the hypothesis we'd set up in the Gambia, but they also have excretion of environmental metals, cadmium, arsenic, a whole range of them. This is southern Bangladesh, and somewhat lower vitamin D status. And so for these children, it does appear we at least are making the assumption that we have a mixed etiology here of a low calcium intake, marginal vitamin D status, poor diet quality, and a contaminated environment. And in fact, over the years, the idea that there is a simple one story fits all when it comes to calcium metabolism has really disappeared, I think. And there's really a subtle interplay of vitamin D with calcium and phosphorus homeostasis, that can be affected at any one of these levels, and that often these problems are a mixture on the spectrum between calcium deficiency and vitamin D deficiency. But this interest in vitamin D deficiency that's come through here led us into some studies on the problem of bone loss in people living with HIV and on antiretroviral therapy. Studies from mostly from America had shown that people, men usually, placed on ART who were HIV positive had a degree of bone loss that occurred, and that this was related to some extent to a vitamin D deficiency problem. In Africa, particularly in East and South Africa, HIV is the high prevalence is very much among women. And we wondered if there was a problem of vitamin D deficiency for these ladies as well. So we undertook studies of premenopausal women and of those in pregnancy and lactation who were living with HIV and about to be placed onto antiretroviral therapy. These studies were in Soweto in South Africa, Kampala in Uganda. And we have shown that bone loss is associated with the initiation of antiretroviral therapy in both sets of women there, but we're unable to show any effect at all of vitamin D. Their vitamin D status looked perfectly reasonable in both sets of women and was not affected by the introduction of antiretroviral therapy. And of course, that bone loss is a real concern. Many people now are managing to live with HIV on antiretroviral therapy well into mid and older life. So the possibility, of course, is that that bone mineral loss associated with antiretroviral therapy may well presage a problem of osteoporosis and fractures in old age. There's a low hip fracture incidence reported in older Africans, and that's been true for many years. It's considered to be much less of a problem than it is in Western countries, but is likely to increase just through sheer demography to some extent of older people living to greater older age in Africa. Now, our studies in the Gambia back in the 90s and repeated more recently in the Gambian bone aging study is that actually in this population, and we expect that to be true in many others, that older people, older Africans, just like older Europeans, have lower bone mineral density in old age. And in fact, one would say they technically have osteoporosis on the basis of bone mineral density measures. They also have high to normal parathyroid hormone levels, which is associated with their low calcium intake, but would be regarded as a risk factor for osteoporosis and fracture in this country. And across Africa, there's a transition towards Western style diets and the inactive lifestyles that again, we think may underpin some of the problem of osteoporosis and fracture in older life. So there really is an urgent need for rigorous research in bone health of older Africans to be undertaken to truly understand that. And I'm very pleased to say that my colleagues in the University of Southampton, Kate Ward, and in the University of Bristol, Celia Gregson, have set up a network of researchers who are interested in this problem across sub-Saharan Africa in order to tackle this requirement for some important evidence gathering and research into the problem of bone health in older Africans. And they have been awarded recently funding by the Wellcome to undertake a very large study called Fracture Z3, which is just beginning underway at the moment, and I'm very pleased that my team in the Gambia is very much involved with that study. But that just highlights, I think, the network that's been set up there, the importance. Another essential ingredient of public health nutrition research are partnerships, and I have put up here a number of those partnerships with whom none of the work that I have talked about up until now could possibly have happened. Not only is it the partnerships with research, but it's also, of course, the engagement of local people. Being able to, the commitment, the enthusiasm and the participation of local people have been true in all parts of the world that I've worked, as well as here in the UK. But that also means the opportunity, of course, to understand local foods and practices, and the context in which one is working, which is so important. And it's been a great pleasure for me and a privilege to have been able, during all of these studies, to have been able to participate in some training of the professionals and capacity development of researchers in the countries, and to disseminate some of the evidence that we've gathered to the local populations. And Paul, right at the beginning, mentioned the fact that the importance that I have always felt of taking some of those findings and taking it into policy and practice. Back in the early 1990s, the Dunn Nutrition Unit undertook to measure the biochemistry in the National Diet and Nutrition Survey. And I became involved at that time for the measurement of vitamin D. And I have been involved with the NDNS survey right the way through to now. I'm still an advisor to the consortium that is currently running the survey. And you heard about my work on SACEN. And in fact, my very first opportunity to interact with that was to chair the Nutrition and Bone Health Working Group back in the 1990s when we first looked at that. And much more recently, I've had the opportunity with the newly formed Academy of Nutrition Sciences to participate in a working group led by Christine Williams to bring together, to collate some of the thoughts about the nature of the evidence base and frameworks that we use underpinning dietary recommendations for non-communicable diseases. That position paper from the working group, I believe, is going to be online in the British Journal of Nutrition this week or next week, and published early in the new year. So at the end of my talk, everything that I've mentioned before, the hard facts, the misfits, and so on, none of this would have been possible without the inspiration of the people that I've had the opportunity to work with, the funding by the Medical Research Council. Practically everything that I've talked about has been funded through the MRC over the last 40 years. And then most particularly for the inspiring and wonderful researchers that I've had the opportunity to work with over this time. And I want to mention particularly the current theme leaders, Kate Ward, who's now at the University of Southampton, Landing Jarju in the Gambia, and the late Gail Goldberg, who is very much in my thoughts this afternoon. My current postdocs and the recent ones, especially those who still owe me papers, I know they're busy writing on them, and the previous theme leaders who, of course, very much helped to shape the direction of the research, and many, many more, the support staff and all the participants in my studies. And so it's really very much on their behalf that I would like to say I'm very honoured to be accepting the Widdowson Award, and I thank you all very much for listening. And with that, I shall hand it back to you, Paul.
Thank you very much.
Thank you very much.
Thank you very much.
Thank you very much.
Thank you.
Thank you.
I seem to have an echo.
I seem to have an echo.
Thank you very much for
an
outstanding presentation. Everything that an award lecture should be in terms of authority, perspectives, and clarity. As you know, we're unable to offer you applause in person. So you have to assume that your lecture has been greatly appreciated. I'm sorry, I keep getting an echo. I don't know whether you're getting an echo too. Okay, it's
no,
just
it's fine from my end, Paul.
Okay, then I'm glad that's the case. It must be something local to me. Certainly, the Widdowson award has been gone to a flying start with presentation. Again, thank you. I know that you have actually received the award in the post, so can I, as it were, formally hand it over to you and ask you to expose it to the world?
I hope you can see that. Thank you very much, Paul. I really am extremely honoured, and I thank the Society very much. And it is a beautiful award as well. Thank you very much.
Well, thank you again, Anne, and you are highly splendid awardee. And thank you to everyone who's been listening in worldwide. And I'll pass back to Professor Julie Lovegrove, our president. Julie.
Thank you very much, Paul, and thank you, Anne, for an excellent presentation. I would like to congratulate again our 4 worthy winners today. Professor Kisatu Nagata for the BJN Outstanding Paper of the Year, Dr. Vimal Karani, who was awarded the Silver Medal, Dr. Richard Skipworth for the Cupferson Award, and Anne Prentice for the award of the inaugural Widdowson Award. I've had the privilege of working with Anne over the past 10 years and as a member of SACN when Anne was chair. Anne is a true inspiration to me and many other nutrition scientists, and a very worthy winner of this award. I have no doubt that Elsie Widdowson has been delighted that you have been received this award, Anne. Many congratulations to all the winners. It has been an excellent afternoon of exceptional nutrition science. I've learned a lot and thoroughly enjoyed every presentation. Thank you to the outstanding presenters. I would also like to thank the excellent chairs, Professor John Mathers, Professor Sue Lanham-Yu, Professor Walter Hans. Thank you very much for being excellent chairs and giving the time this afternoon. This event would not have been possible without the hard work of the Exceptional Nutrition Society team, led by our CEO, Mark Hollingsworth, who is supported today by Carolina, Jade and Cassie. Huge thanks to you all. I would also like to thank all of our delegates who have joined us from near and far. I hope you all enjoyed the event as much as I did. I look forward to seeing you, many of you, at our Winter Conference Live 2020, our 2-day event which begins tomorrow. This focuses on topics related to micronutrition throughout the life course and promises to be another excellent event. 2020 has been an extremely challenging year due to the impact of the coronavirus pandemic. I hope that you are able to have an enjoyable and peaceful Christmas with family and friends, and that 2021 brings a return to normality as we win the global battle against COVID-19. Finally, before closing the award ceremony 2020, I would like to wish you all an especially happy Christmas and a healthy new year. Thank you very much.